Hello, AP Physics 1. So this will be my first video of 7 that I'll make for you to help you review for the AP test this year. I'll go in the order of the units of the course, so we'll start with kinematics and then go on from there, ending in rotation. Each video, my goal is to create a kind of review sheet for you with the most important understandings and key details that I think might be important on the exam. But this year's exam will be like none others. So I'll try to predict things the best I can, but I can't guarantee anything. So I'll do my best, pull out the important details as I see fit, and create a sheet to help you out. If you have questions that can't be found in the video, please email me or save them till Monday for our meeting, and you can ask them, and I'll try to explain more. Each of these videos will also come with a problem. You'll do an FRQ problem that I'll assign on AP Central that I will grade for you, and I'll also create a review video about. So you're gonna have a lot of content coming up. I hope you find it useful and you can give me some feedback on Monday with what I did well and didn't. So now let me switch over to my document camera and we can start on this. So the first thing I would understand in kinematics is that you need to understand kinematics, if we're going to use algebra, as motion in an x direction and or motion in a y direction. These equations that you're dealing with only work on a single plane at a time or within a linear motion setting. There are 5 variables that are interested or you care about when you're doing kinematics. They are displacement, initial velocity, final velocity, acceleration, and time. Same for y. And as far as kinematics goes, the one that's really interesting here and the one where kinematics is really important is with time. Time right here can go from one side to the other and back and forth. It doesn't have a y or an x attached to it. So when you solve for time in the y, it can go to the x. When you solve for time in the x, it can go to the y. They are transferable. They give you the needed variable to calculate what's going on here. And also, importantly, is generally, what's your acceleration in the y? In a lot of problems you're dealing with in kinematics, this is often going to be your g. Not always, but in free fall problems, this is going to be g, which versus your acceleration here in the x is often 0 in those free fall problems. And you'll have to keep that in mind. Let me put free fall there for you. Awesome. Of course, there are a few kinematics equations that you should be aware of. V equals d divided by t, velocity equals displacements divided by time, but only when you have a constant velocity. Then there's your acceleration or your constant acceleration equations. Acceleration equals the change in velocity over time. Displacement equals 1/2 acceleration times squared plus initial velocity times time. Final velocity squared equals initial velocity squared plus 2 acceleration displacement. And then this equation, which isn't on your AP sheet, but certainly is important in some cases, you can kind of derive this one by using graphs, but here it is. Let me write it out. And it's that displacement equals your initial velocity times by your final velocity divided by 2. So kind of average velocity times by time also works. And so these notes are here. Now we're not constant velocity, but we're a constant acceleration situation. And the key is whenever you're using these equations, you need 3 knowns for them to work. For example, to use this equation, you need to know 3 things to solve for the other thing. Often, you know acceleration, you know time, you know initial velocity. That gives you displacement. So the key is you need to know 3. You can think of that here, or you need to know 3 of these 5 that are listed here. The AP, I'm guessing they're end up going to give you a pretty difficult problem when all is said and done. Something that you can't easily look up online in the time they are providing to you. So as far as kinematics goes, if I was to bet on it, I bet they would give you something related to projectile motion in at least part of the problem. It may not be a complete projectile motion problem, but it may be partly. And the key here is using your XY table. Using your XY table, solving for time in the Y often is the key. Using this equation, D equals 1/2 AT squared plus VIT. And the key in the Y, often in these projectile motion problems that are often like this, you have a table and you have an object that falls off the table. That your initial velocity in the Y direction is often going to be 0. So that term's going to cancel. We can simplify this to solve for t, and that would be 2d over a square root if I was to solve for time. I solve for time, and always the interesting thing in this problem is all your acceleration, because you're in free fall here when you fall off, is in the y, not in the x. So in the x, we're using this equation, v equals d divided by t. You're moving your time from the y over to the x, and then solving for either the velocity when it left the table or the displacement in the x direction here. Key being, use your XY table, solve for time in the Y, place it in the X. Constant acceleration here, constant velocity over here. And if you got projectile motion, this is the type of problem I would expect for you to see. You can certainly go back to your book or look a bunch of other places if you want to do a worked example of one of these projectile motion problems. So this is kind of an algebraic understanding, but you should certainly have a graphical understanding too. So I'm gonna pause the video and set up a sheet, and then I'll come back and explain what that sheet is. All right, welcome back. I'm gonna describe what's going on here, and then you may want to kind of pause the video to kind of get your sheet to where mine is right now. So as I start to sketch out these graphs, you can follow along and sketch them out yourself. So there are 3 types of graphs in kinematics. Those are time versus position graphs, time versus velocity graphs, and time versus acceleration graphs. Notice time in these basic graphs are always on the x. The AP may do a funky graph where that's not the case, but in these basic understandings, time is always on the x. Then position, velocity, or acceleration is on the y. I'm going to go through the 5 most common cases to understand graphically. That's it. If an object is at rest, at a constant positive velocity, at a constant negative velocity, and at a constant positive acceleration and a constant negative acceleration. I'll need to add a few of these at one point going into the negative, but we won't worry about that yet. Let's start about rest. So if I have an object at rest, its position does not change. It's at rest. It's staying in the same place. Therefore, it has a zero velocity and a zero acceleration. Let's read on the constant positive velocity. My position changes the same amount over each given period of time in a constant positive velocity. If I was to take the slope of this line, I would get one positive velocity. One positive velocity. When my velocity is constant, I have zero acceleration. Let's go on to here. Now I have a constant negative velocity, so I need a negative slope. Negative slope. I need not just positive, but a negative velocity. Positive here, negative velocity here. But my velocity is still constant, so my acceleration is zero. Let's move on. Now with a constant acceleration, I get a curve. I am changing my position more now as time goes on. Now if I look at this graph, my slope is now my acceleration. Notice it's constant positive. And my acceleration is constant in the positive. Now let's move on to the last one. What if I have a constant negative acceleration? Well, now I have a graph that looks like this, where my position change was a lot, but now it's getting less and less and less. My velocity started out high, but got less and less over time. And now I need a negative for my acceleration. Constant negative acceleration. I'm losing velocity. My position is changing less and less over time. And that's all I have for this video. Your algebraic understanding, as it gets complicated to projectile motion with your equations and the 5 variables of kinematics, the most important one being time, which doesn't show up in energy, which often can be used to calculate some of these problems too. But if you have time, it's often always you're talking about kinematics. And then your graphical understanding too. So if you have questions, let me know. But there you go. There's your first lecture or review for kinematics. I will be posting this along with a review question in AP Central to help you out with kinematics. Have a good day.